Well, good evening, everyone, and thank you for taking an interest in design and technology. If you haven't met me before, I'm Mr. Jones, Head of Design and Technology, and I'm going to start by saying how proud we are, very proud of the hundreds of students that have taken GCSE Design and Technology at JCG over the years, students that have gone on to become product designers, architects, doctors, lawyers, a full spread of careers, yet they've loved their design and technology and benefited greatly from it. So I'm going to take you through the presentation, excuse me, which basically outlines what the course is, but also what it gives you as a student. Starting off with, if you take design and technology, you'll be joining a well-established and high-achieving department. That's actually fact. We've got outstanding facilities and resources. We're very lucky to have an extensive design centre with lots and lots of resources in there. And we have consistently high results. We have a committed and caring team of staff. Both myself, Mr. Cockshall and Mr. Nicol are the full design and technology team who bring together a lot of experience to help you through the course. And of course we care. We're going to be there and we will help you through it if you choose this subject. It's a popular option choice. Students at JCG do tend to enjoy their D&T, and we currently have in year 10, a third of the students in that year group taking design and technology. So you'll be in good company. And in the past, JCG projects have been used by OCR because the actual exam board we use is OCR, and they have been suitably impressed by the work that the girls have done in the past, and they have frequently used their coursework, their NEA work, as exemplars to train teachers up and down the country. Now, this is a slide which is worth thinking if you're sort of trying to decide whether to take design and technology or not. It's popular misconceptions versus the truth. First one, design and technology is not a soft subject. It has an academic strain running through it. There's plenty to learn, plenty to achieve, but it has this, it's like science and maths and design all meeting together. So it's quite a package, and we'll look at that moving forward through the presentation. I believe, which it is a valuable education for all. I don't think it's for the chosen few. It's why we afford quite a bit of the time at Key Stage 3. And we're lucky to have that time each week. And it will prove your creative capabilities and provide you skills for life. It's well respected by university courses, without a doubt. And another one, you do not have to be good at art. The graphic skill obviously helps, but some of our best students in the past have been quite challenged at drawing, but what they're using is their creative brain to actually design products. So it's not an essential. And the last bullet point on this slide is you are all capable of successfully taking GCSE design and technology. And I really mean that. You've started on the road in year 7. So you've had 3 years of it so far. Why not continue onwards with that? Results obviously matter. The education is of paramount importance, what you gain from it. But yes, the results matter moving forward. We all know that. And this slide will help to prove our consistency over the years, because it has been the sort of similar statistics for many a year now. Last year we had 81% grade 9 to 7 and a handful achieving grade 6 and 5. This year, and this I must admit, we actually targeted those who needed a bit of support with the NEA in various areas. I mean, we give all students support, but there was a particular area that we noticed students were struggling, and we were able to convert more of the grades into 9s and 8s. So 83% of the students got 9 to 8, and 17% got 6 to 5. Okay, some of those students really worked hard and were really chuffed with that grade, and definitely felt accomplished. Others went away knowing that they probably could have done more. Now, here's the course breakdown. You have one exam, which will be at the end of year 11, and that is worth 50%. And we'll look at what that contains in a minute. And the unit 2 is the NEA, which some subjects have retained coursework, and we're one of those subjects, because I don't believe you can assess design and technology without designing and making things, and that's exactly what it is. You will do a big design and make project, starting off at the end of year 10, but then carrying on through to the end of year 11. The Principles of Product Design exam, worth 50%, as I've already said. It's a written exam, usually in the hall under exam conditions. And in June 2024, we will hopefully have prepared you for this. It tests your core and in-depth knowledge and your understanding of product design. So how things are made, what they're made of. And you will get pictures, as you can see in the picture there, of something like a product like a bicycle, and you'll be asked about the materials it's made from, how it goes together, as well as some of the wider issues, the wider, more global issues like the environment and the impact of the products that are being made and used across the globe. Generic design factors. Now this is gold dust, really. When you think about, I've been talking about the package of design and technology, and just have a look at this for generic design factors. You will get an understanding of materials and properties, manufacturing and production, digital technologies, ergonomics and anthropometrics, environmental considerations, social and moral impact of product design, global manufacturing and economics, fashion, style, obsolescence, systems and control, mechanisms and forces, health and safety in the workplace, and advertising and marketing. And if that isn't a package that is relevant to practically all careers, I don't know what is. You know, this is where the real depth of the subject can benefit you. Now, there is maths in there. 3 years ago, the new syllabuses came out, and there is about 15% maths in the exam, and you have to use your maths ability when you're designing and making in the NEA project. At first, we were thinking, oh, is this going to turn students off? Not that maths is a bad thing, obviously, it's a very good thing, but what we found is the students that took the first exam reassuringly said to us that the level of maths is well within the grasp of students at Gcse. It's applied. So if you have to work out angles, there's a lot of trigonometry in there. Angles, if you're and in the NEA, if you're designing something with a cylinder, you have to work out the volumes, the surface areas, etc. It's all good stuff, and I can see why it's in there, because it is. It has that engineering strain running through it. And it's the same with science. You know, we might look into biomimicry. What can nature teach us about how to design products? And we look into biomimicry, but it could be anything to do with physics. And if your project requires you to work out the speeds and the revolutions of things, then you look into that, the physics side. It could come from anywhere. It could be chemistry. But it all adds to the richness of your design experience. Now, the NEA, as I say, is nearly a year long. The themes come out on the 1st of June at the end of year 10. They're very broad, but the big thing to remember if you're going to take design and technology is that that brief isn't the design brief. What to design and make isn't given to you. The rough theme is, like for instance, exercising at home or pet care. They're broad themes. What you have to do then is go and engage with a stakeholder, an expert out of school of your choice in an area of your choice, and you find from the experts what to design and make, and they help you, that you can go back to them for feedback and advice a couple of times during the design process. And it all ends up with a fully working prototype, which is pretty impressive when you finish, and you go back to your stakeholders and you can test your prototypes there. So design-wise, for the NEA, you're on familiar ground, you're researching, you're sketching like we've taught you to do, and we've got lots of computer-aided design now, and you're modelling. And we take those skills further, skills that you've already started. And the actual prototypes, here we've got a prototype for one couple from a couple of years ago. One is a buggy that marks out a cricket boundary without somebody having to stake it out. It is tied to the post and goes around an elliptical route and actually marks the boundary. There's a little device down at the bottom to help people teach sailing. There's a bicycle charger and lock, and a woodwind musical stand. Just a few of the hundreds that have been produced. There's plenty of ICT within the package. Obviously it's an integral part of design. So we'll be word processing using Excel, all our design suite of computer-aided design software, SolidWorks mainly now, TechSoft 2D design, and lots of computer-aided machines, computer-aided manufacture, and we've got machines. So the 3D printers are very useful. The laser cutter is useful as well, and you will become well versed in the use of these machines to support your design work. All very current. Digital technology at your fingertips. Now this slide I wanted to put in because people say, well, okay, I hear this, what's it giving me? Well, moving ahead, and this is where I said about right at the beginning about a vast array of careers that girls have gone on to, because D&T shows they can be creative, that they can be innovative, that they can be resourceful, they can solve problems, they're original, they can manage projects, they can, it is very business orientated what they're doing. You understand sustainability, you can communicate in many ways. You can be intuitive, use your initiative, practical skills, I think are very important going ahead. Knowledge of the man-made world, which is huge, health and safety, ICT, and you get a knowledge of digital technology, CAD and CAM. Valuable wherever you're heading. Just going to mention this briefly. We do offer the Arkwright Scholarship for those of you who are thinking of then going on from GCSE to take maths A level, and if you're thinking of becoming an engineer, you could apply through DT for an Arkwright Scholarship, and there's Rachel there. And Annabelle received her scholarship. You probably saw this in the press for her, where she passed the actual test to get a scholarship, but it started with her project, which was a medicine dispenser that delivers the pills or whatever with a shot of water. Excellent stuff. Looking at some of our, here's A level, shows you that we're we have a very strong A level course, and very similar outstanding results. Important to know if you're thinking further from GCSE. And here's some of our alumni, just a handful of the many girls that have studied D&T at JCG. Nicole Murray has her own interior design business down on the waterfront next to Tiffin's. Rachel Hayden, who went on She could have been a sportswoman. She could have been an opera singer. She could have been a lawyer, doctor, but she chose engineering, and she's gone from strength to strength. She's won Student of the Year, and she's currently working on the nuclear power development at Hinkley. Sam Bouchard's out in Vancouver with her own architecture business. Kenya Smith went to Loughborough University to do product design. Don't know whether you know any of these girls. And to finish up then, a GCSE in design and technology is respected common currency wherever you're heading. The industry is definitely crying out for female engineers and designers, and we have direct links with professions like architecture, product design, interior design, mechanical engineering, and many other creative careers. That's my little statement here. Without designers, there would be nothing new, and the human race would not have developed, which is true. And there's a tremendous amount of career opportunities. I think I'm repeating myself there. But Britain needs engineers and product designers. Design and technology is what the economy is about, designing, producing and selling it to the rest of the world. And the government, interestingly, the government treasury predicts that half of all available jobs in the future will be creative. So thank you for listening. I'm going to turn on, I'm aware that there's quite a big delay, can be up to about 10 seconds. So I'm just going to turn on Q&A now, hoping it works. And if I see any typed questions up there, I'll try and answer them. I have a good turnout, 37 attendees. Thank you very much. If anybody's got any questions? I'll run out the time till 10 past to give you a little bit to think of some. You may be talking about some of what I've said right now. Oh, how many times a week will we have if you choose it? Great question. Year 10, you have 2 lessons a week for all the foundation year, the work, and year 11, when you're doing your NEA, and of course we're still working towards the paper, you get 3 lessons a week, 3 hours. So that's great, really good. Is the coursework mostly PowerPoint? It's presented on PowerPoint. I would say the coursework is mainly, it's a doing subject. So we're either researching, sketching our ideas, modeling our heart out, making our heart out. You know, it is a doing subject. So yes, it all gets presented on a PowerPoint, but you are certainly not sat in front of a PowerPoint. That's it. You write up the activities. The main activity is designing and making. So ask the girls in the year above. You know, we keep that going. We don't want you sat there just working through theory all the time and typing away. It's designing and making, which is what I hope you love. Thank you, Susie. What are some of the examples of themes at the end of year 10? As I say, we had exercising at home. That's a COVID-related one, I reckon. It could be recreational activities, pet care. They're very, very broad. Looking after nature, looking after the environment. So yeah, they're very broad, and we can usually fit in whatever you find that you're interested in will fit into one. Do we get help and advice in choosing the expert? Lots. I make sure that any interaction with somebody outside the school is really carefully thought out, and we're experienced at that now because it is quite tricky. Okay, maths and DT, it shouldn't be a problem. As I say, the girls that have gone through it say that the maths involved in the DT is well within the actual capabilities of all JCG students. It's applied. I wouldn't worry about the maths at all. And we've got Mr. Coxall, who came to us from maths, so plenty of help there. If you're worried about it, I wouldn't let the maths put you off. And you can come down and have a look at some of the questions if you're worried about it. Yes, there's a textbook. It's the OCR GCSE Design and Technology. It's got a light bulb on the front. It's published by Hodder, and you will get details of that book but we don't really teach via textbook. We use it to support. We've got our own well-established delivery. Okay, folks, I think I've got all the questions. Is the level of physics similar to the maths? Absolutely. In fact, the physics, you don't get direct physics questions. The physics comes more when you're designing something for your NEA. So we could run off to see Mr. Aguiar if I was stumped. I mean, Mr. Coxall's got an engineering degree. I've got a technology degree. So we should be able to help you work out the physics that are involved, but it's very, very low level. They just want to make the link with physics, maths and DT. But if you want to, you can run off with your project, see Mr. Aguiar, and he'll solve it for you. Okay, folks, I think that's it. That's a wrap, as they say. Do not hesitate to contact me if you've got any other questions, and girls, if you want to see me, come down at lunchtime or chat to me in a lesson if you've got any more questions. Great to see you. Thank you so much. Speak soon.